Good evening, all of you. So, in continuation of our last lecture, today we'll start with the major characteristics of conventional machining as well as non-conventional machining. Because last lecture we have discussed that why we do need our conventional machining processes. Okay, basically on the session characteristics about the conventional machining or we can call traditional machining. And that first is the microscopic chip formation. Okay, as we have observed many times, generally while doing the machining operation, okay, using our conventional machining, we are getting microscopic chip formation. Okay, whatever the removed from the workpiece now, that is in the form of microscopic chip. Okay, again for the conventional machining, for metal removal, we need a cutting force. Okay, and that cutting force usually it comes from the energy driven like from mechanical only, because we are applying the force, then and then only our cutting tool will move towards the your workpiece, and through that that edged cutting tool metal removal process will start. Okay, so metal removal takes place due to application of cutting force. Okay, and their energy domain that can be classified as a mechanical one. Okay, then a very important point or a major characteristic about the conventional or traditional machining, we can call that whatever the cutting tool we are using for the conventional machining process, no, its hardness should be larger than the workpiece. So that is a major characteristic. So in short, I can call cutting tool hardness. Cutting tool should be harder than the workpiece. Okay, as well as in the conventional machining, as we know that there is always physical contact between your tool, okay, maybe a tip of tool, and your workpiece. Okay, from where you want to remove the material. So these are the major characteristics of conventional. Now we'll move towards the major characteristics of non-conventional or non-traditional machining. Okay, so in that whatever material we are going to remove from your workpiece using the any conventional non-conventional machining method, that is always in the form of small microchip. Okay, so or even sometime whatever if you take the example of EDM or laser cutting, there is no chip formation. Okay, so here I have written it may be sometime we will get the chip formation or even no chip formation also. Then as we come from got the point from the our that why to go for advanced machine, that we do not or we no need to go for the physical tool. Okay, so for non-conventional machining, I can say we do not require any physical tool. Then next point will be that whatever the tool is there, so there is no barrier about the its hardness. Okay, tool need not be harder than the workpiece. Okay, this is a major difference between the conventional and non-conventional. Okay, tool need not be harder than your workpiece. Okay, and the most important characteristic about the non-traditional machining is that here we are going to use we are using different kinds of or different energy domain. Okay, for providing the machining, or we can call to remove the material from the workpiece. So whatever the third point and fourth one is, so that is important. Okay, tool need not be harder than the workpiece. Okay, this is that means we do not have any barrier about the tool strength, or we can say in another word, no need to go for the harder tool. Okay, then here we are using different kinds of energy or different energy domain we are using for providing the machining. Okay, and depending on that we have different types of non-conventional machining. Okay, for example here itself I can say if you use that abrasive particle. Okay, and if you use kinetic energy of that abrasive particles, then that process is called abrasive jet machining. If you use water, then it is called water jet machining. Like that, if you use the electrical energy, then electric discharge machining. If you use chemical energy, then chemical machining. Okay, so like that. Again, if you use thermal energy, okay, along with the electrical energy, then laser beam machining, electron beam machining. These are the different non-conventional machining processes. Okay. Now, as already we have discussed about the advanced machining, where to go for advanced machining. So similar, as per the syllabus, we have the point that is need for non-conventional machining. Okay. Now, as we know that whatever our conventional machines are there now, so that are specific to the requirement, that requirement of industry, okay, from last over the decade. But for whatever new coming materials are there, or we can call new exotic work materials are there now, as well as we can call innovative geometric design of your product and your component. So that are their requirement, it is not fulfilled by the our conventional machining process. Okay, so they are putting a lot of pressure on our capability of our conventional machining process. Okay, because using conventional machining, we cannot go for the machining of new exotic work material, or we can call for innovative geometry, the geometry of your product. Okay, so there is some limitations of capability of our conventional machining process. Okay, and to manufacture such component with desired tolerances, we require some new processes. So this will lead to the our development, as well as we can call establishment of advanced machining processes or non-traditional machining processes in the industry. Okay, so whatever our non-traditional machining processes are there now in the industry, they are efficient as well as economic alternatives to your conventional machining. So in general, this is a need for our non-conventional machining. Also, with the development of in this non-traditional machining process, currently there are first choice in the industry. Okay, not just alternative in the industry, they are referring as a first choice of this non-traditional machining. Okay, not only alternative to conventional machining, because whatever we in the industry, whatever there is a certain technical requirements are there now. So to fulfill that, there is a need of development in the non-traditional machining process. Due to that, they are going for micro machining also. Okay, along with this advanced machining process. Okay, that is new. Now, whatever I have mentioned the points in this slide now. So these are the examples. Okay, that are provided where the non-traditional machining processes are preferred over the our conventional machining process. Okay, so these are the examples. Okay, where non-traditional machining processes are preferred over the conventional machining process. Now, if you see in the slide, on the slide, so first example I have given that integrate shape the blindfold. Okay, again in that we can take the example that if we want to drill a square hole of 10 mm by 15 mm, okay, along with depth of 30 mm, so it is not possible using our conventional machining. So to drill this integrated shaped blindfold, we need only non-conventional machining or advanced machining process. Okay, integrate means what? In Marathi we can call guntagunti cylinder. Okay, then next need is that whatever the materials are there which are difficult to machine. So to machine the material which are difficult to machine, we need only advanced machine process. Okay, so in that again, for example, okay, same example as I have mentioned above, no? But if the material of workpiece is inconel or that titanium alloys or carbide, then it is not possible using our conventional machining. Okay, because whatever the materials are there, no, inconel or the carbide or some alloys, they are very hard. Okay, and they are difficult to machine. Okay, so for that purpose we need non-conventional machining. Again, in that material, if you want to go for drilling of the square hole of that fine hole, that is 15 mm by 15 mm, then it is difficult. So for that non-conventional machining it is sufficient. Again, what are the low trace grinding is there, no? So for that purpose again, now this low trace grinding, it is not possible using our traditional machining. What are the electrochemical we can use for grinding? So in combining that is grinding is traditional. Okay, that really is used in the electrochemical machine. Then it is preferred for the low trace grinding as compared to our conventional grinding. Okay. Then for deep hole with a small hole diameter, no? For that purpose, now using our conventional machining, maybe this deep hole with the small diameter, small hole diameter, so that activity may be performed using the our using example. If the hole diameter is 1.5 mm and also that ratio of inner and outer diameter maybe 20, then it is that small not possible using our, or it may be difficult using the conventional machining. So we need to go for conventional, no, we need to go for non-conventional machining process. Okay, then again, as I have mentioned that nowadays there are new exotic materials are there, new innovative materials are coming, like that composite materials are there. Okay, in metallurgy we know that composite having the separate category. So to machine for machining of the composite materials, we need advanced machining processes. Okay, so these are the different needs from which we can say we have to go with the our non-conventional machining or non-traditional machining processes. Okay, and now if we see, now after getting the information about the advanced machining process, we need to move for the its classification. Okay, because we know that energy domain, it is important for the our non-traditional non-conventional machining process. So whatever the classification is there, depend on the energy domain. There are so in that we have the category depend on the energy domain. So mechanical domain, that is mechanical energy based non-conventional machining process. These are that are different. Then thermal energy based or thermoelectric we can call. Then electrochemical energy based processes are there. Then chemical is there. Okay. Now in that again, before that, depend on the what are the workpiece material is there now. That means what are the properties of workpiece is there that workpiece to be machined now. So again, based on that also we have the classification. Okay. So classification may be depend on the different criteria. In that again, I can say whatever the advanced machining processes are there, no, they use different kinds of energy in their direct form. Okay, for example, if you take the example of laser beam energy, or electron beam energy, or ion beam energy, electric spark energy, and so on. So depending on that, we have the different classification. Okay, in general, what are the material remote rate is there now in this advanced machining processes? That is normally it is very low. Okay, but definitely what are the quality of the product is, it is better than the what you can achieve by our conventional machining process. Okay, so however in these advanced machining processes now, what are the initial cost is there, that is also very high as compared to our conventional machining process. Okay, for example, if you take a good lathe, okay, then that lathe can be about for about I can say 10 lakh or so. But if you go out to buy simple electrochemical machining or EDM machine, then it will not come less than the euro 20 or 20,000. Oh, sorry, 20 lakh. Okay. So on the other hand, whatever the electron beam machine there, again for electron beam machining, cost is more than the 50 lakh. Okay. So here, whatever the initial investment is there, that is very high for the advanced machining processes. Okay, or that machinery. Okay, now come to the our point, that classification. So classification of this non-traditional machining process can be done based on the different criteria. Okay, so in that one of the criteria is the, firstly I will tell the type of workpiece to be machined. Okay, type of workpiece to be machined. So there are certain processes which are applicable only for the electrical conductive metal. Okay, that means if your workpiece is electrically conductive metal, then and then only your some advanced machining processes can be used. Okay, now in that I can tell example that electrochemical machining or electric discharge machining or even electron beam machining. Okay, not always. So these processes you can use only for the electrical conductive metal. Okay, so so this may be one category of your process. Again, there are certain processes which are applicable for both your electrically conductive as well as electrical non-conductive material. Okay, if your workpiece material is electrical conductive as well as for example if you take another way electrical non-conductive also, then some processes just like ultrasonic machining, abrasive jet machining, laser beam machining also. So using that machining processes, you can do machining operation. Okay. Again, there are certain processes which are very good for non-magnetic materials only. Okay. Okay. So this is again third category, based on the properties of work material to be machined. Okay. So certain processes which are very good for non-magnetic materials. Okay. While they are not so good, I can say, for magnetic material, and those processes are like magnetic abrasive finishing, EMAF, then magnetorheological finishing. Okay, these two processes are not in our syllabus, but for your information, I am telling this category where whatever the magnetic field is used now for assisting the process that we will get from that process only. So there are again certain processes are there whose performance is totally depend upon the thermal properties of your workpiece material. Okay, now the processes whose performance is totally depend on the thermal properties of your workpiece material. Now thermal property means which are that property like thermal conductivity, specific heat, then reflectivity. Okay, in that again optical or thermal, etc. Okay, so these properties plays an important role in certain processes, especially in case of I can say laser beam machining. Okay, so if the component has a high reflectivity in case of laser beam machining, then that laser beam machining cannot be work sufficiently. Okay, if the components have high reflectivity. Now, on the other hand, I can say, although the conventional machining is machining process are there, no, like turning, milling, drilling, etc. So they do not have any such kind of constraint about the properties of workpiece. Okay, so Only in case of this our non-conventional machining process, you can use mechanical type of advanced machining processes and mechanical type of finishing process also for all kind of materials. Mechanical machining process are different, and mechanical type finishing process are different. Again, whatever the chemical and electrochemical machining process are there, that are also can be used for electrically conductive material. Okay, then however, whatever the electroconductivity in uh, chemical machining, so that is not required for chemical machining, that electrical conductive property. Okay, again, if you take the in case of electrically non-conductive material, so again for that category also different kinds of conventional machining process like turning, milling, or drilling can be used. Okay, for electrically non-conductive, and for the again further I can say for non-conductive material, mechanical type of machining, that is abrasive jet machining, ultrasonic machining, abrasive water jet machining, abrasive flow machining, then water jet machining, magnetic abrasive finishing process can be used. Okay. Again, in case of thermoelectric advanced machining process, thermoelectric advanced machining process, in that again laser beam machining, okay, LBM, then plasma arc machining, PAM, ion beam machining, IBM can be used for the thermoelectric. Okay, again for chemical advanced machining processes and biochemical machining process, so that machining processes you can use for the material. It may be electrically conductive or non-conductive material. Okay, so that was the classification based on the your properties of the material, that workpiece material which is to the machine. Now come to the main classification of this non-traditional machine, that is classification of these various non-traditional machine process based on the which kind of energy they are using for the material removal purpose. Okay, so let us discuss the classification of various advanced machining processes based on the different kind of energy used. Okay, in that here I have mentioned that these can be classified according to the source of energy used to generate such a machining action. Okay, now source of energy or domain I can say mechanical energy is there, thermal energy is there, then chemical is there, electrochemical energy is there, and again there is a biochemical also. Okay, in the classification, but as per our syllabus, we should concentrate on this mechanical, thermal, chemical, and electrochemical only. Okay, now in that again, okay, if you take the mechanically energy based process, now mechanically energy, then basic question will arise that how the material removal process will happen using the mechanical energy or in this mechanical process. So there, a erosion of your workpiece material will be uh, happen by high velocity stream of your abrasive or your fluid or both. Okay, so whatever the erosion is there, that is the typical form of your mechanical action. Okay, so due to erosion of your workpiece, material removal will happen. Now, how that erosion is going to happen? So, okay, so for erosion purpose to happen, that erosion, we need high velocity stream of some fluid. Okay, now in that, if you use high velocity stream of abrasive, then the abrasive jet machining it is called. And if you use water, high velocity stream of water or water jet, then that process is called water jet machining. Okay, and if you combine use, then abrasive water jet machining. So for mechanically energy based process, erosion action is important because due to the erosion action only material is removed from your workpiece. Okay, now in that again, which are the different types mechanically energy based? So already I have mentioned that abrasion machining, ultrasonic machining. In short, abrasion machining AJM, then water jet machining WJM, then water abrasive water jet machining AWJM, and lastly ultrasonic machining USM. Okay, so I repeat, erosion of work material by high velocity stream of abrasive or fluid or both. Okay, it is a typical form of mechanical action. Okay, now let us look for the second energy, that is thermal energy. So this is second group, that is thermal energy based non-conductive machining. Now in that, what are the thermal energy is there now? So that thermal energy is applied to a very small portion of your workpiece surface. Okay, so thermal energy is applied to a very small portion of workpiece, and that will that causing that portion. What are the material we want to remove from that portion? So there, due to the application of thermal energy, that heat energy, fusion and that vaporization of material will be happen. Okay. Now, from where we'll get this thermal energy or that heat energy? So to get that thermal energy or that thermal energy, it is generated by conversion of the electric energy. So this group is called electrothermal energy or thermoelectric energy based process. Okay. So I repeat, here material is removed using heat energy. Now heat energy will need to generate from your electric energy. Now how heat energy is going to remove the material? So if you use continuously that heat on your workpiece surface, so a small portion, then there due to the fusion and the vaporization, that means the melting, that fusion and that vaporization will be happen from that your on that your portion. Okay, from where you want to remove material. Okay, so please note on this, that fusion and vaporization of the material is the action of your material removal. Okay, in the case of this thermal energy or thermal based processes. Okay, now next is the electrochemical energy based processing. Now electrochemical means what? Here is simple. Okay, here what are the electrochemical dissolution is done. So due to that dissolution, electrochemical dissolution, material removal will be happen. Now we know that electroplating. So reverse of that electroplating is that mechanism of electroplating. You take in a reverse way, then electrochemical dissolution will happen. So that is the main action in this group. Okay, so mechanism of the electrochemical machining is the reverse of electroplating. Okay, reverse of electroplating. Now here again, I forgot to mention the good example of thermal energy process, that whatever your electric discharge machining is there, wire electric discharge machining is there, laser beam machining, that again electron beam machining, plasma arc machining is there, then ion beam machining. So that are belongs to the thermal energy based, I can say, or the thermoelectric energy based process. Okay, and then electrochemical process. In that, your electrochemical machining will come, then electrochemical grinding, okay, ECG, ECM. Then electrojet drilling is there. Okay, that has replaced actually electrojet. Okay. Then we have the last one, that is chemical. Okay. So in that again, due to the chemical attack of a certain acid, no, we can remove the material from the workpiece. Okay, so there chemical dissolution is important, and due to that chemical, if you, for example, one small, if you take the plate of copper and if you put in any chemical, okay, again, whatever the chemical is there, that must be uh, react on your workpiece. So due to that reaction, material will be removed from the workpiece of work from the portion of workpiece. Okay, so agent is used to attack on your workpiece. So that certain chemical we can call it is called agent. Okay, so in this chemical machine, actually chemicals are selected. Okay, to remove the material from your portion of workpiece or work art. Okay, now from where we want to remove the material using the chemical machine, no? So from where material we want to remove? On that portion we are keeping the etchant. Etchant means one of the chemical. Now which type of etchant is used and different things are that we are going to see at the time of chemical. But the portion from where we want to remove the material using chemical machine, so on that portion we are keeping or we are pasting chemical, it is called etchant. Okay, so that etchant will try to will try to act react on that your workpiece. Okay, and another one, so on your workpiece maybe other portion will be there. Okay, from where you do not want to remove the material, so that must be protected from the etchant. So the protection which are used on your workpiece from where you do not want to remove the material. So that protection it is called the masket. Okay, kitchen and masket. Please remember. Now here in short, here you can see under mechanical which are the machining and which are finishing process. Then in the group of thermoelectric which are the different processes. In the group of chemical and chemical which are the different processes you can see. Okay. Uh, uh, if you have the notebook and pen, then please write down this within 1 minute. Just write down because this is important. Okay, whatever we have the syllabus for the chapter number 2 to 5th, we have this much syllabus, except this biochemical machining and except this finishing process. Okay, but for your knowledge purpose, I have mentioned that biochemical machining it is also part of our advanced machining process. Okay, in our syllabus we don't have the finishing method. Okay, if you want to go in detail about the finishing process, now you can refer the reference book. Okay, advanced machining process by the Wikigen. Okay, in our syllabus we have the AJM, the WJM, then USM, AWJM, then this in LBM, EBM, EDM, okay, IBM, then CAM, ECM, ECG, PCM, CHM. The all courses we have in our syllabus. So now one by one we are going in detail about the working principle about each and every process. Okay, that's called overview of the non-conventional machine processes. Within 1 minute, please write down. This is important. Okay, have you got this point? Okay, how this classification is then based on the energy domain which is used for machining action. Okay, or we can call according to the source of energy which is used to generate such a machining action. Now, here important part is that as we know that our advanced machining processes or non-conventional machining process, we are divided into three normally basic three categories. One is the mechanical, then this second is the thermoelectric, and the third is the chemical and electrochemical machining processes. But here important is that none of these processes is best under all machining switches. Due to this point only, I have one for that classification based on the properties of your work. Okay, so please remember that none of these processes is best under all machining switches. Okay, so some of them can be used only for electric conductive material, while some of this can be used for non-conductive material, while other can be used for both electric conductive and as well as non-conductive material. So for some cases there may be condition of the your thermal conductor also. So depend on that situation or depend on the property of workpiece, you need to select the best one or best suited non-conventional machining process. Okay, and what are the performance of these processes are there? No, so the performance of some of these processes is not very good. Okay, please listen carefully. Okay, so what are the performance of some of these processes? It is not very good. Now, performance is what? Your surface finish, or maybe firstly you can take the material removal. Okay, in some cases surface finish is good, but material removal is very less. Okay, in some cases MRR is very good, but surface finish may be not good, like that. So performance of some process is not good, while machining material, okay, like aluminum having high thermal conductivity. Okay, also these machining processes have there some distinct characteristics. Okay, or we can call some features also. Okay, so that we are going to see one by one. Okay, so whatever the selection of this all from this all machining process, no, that should be done very accurately as well. I can say appropriately. Okay, so selection of this appropriate machining process for a given situation. Okay, or we can call as per the product requirement. That is very important. Okay, so to select one test process out of this all, it is very important, and to get one best out of this, you should have the knowledge of all processes. Then and only you can choose one best. Okay, now whatever I have mentioned the mechanical advanced machining process, no? Like your average jet machining, AJM it's called, ultrasonic machining, USAM, and water jet machining. So they have some they have developed. Okay, they have developed, but with some limited success only. Okay, average jet machining have some limitation. Then ultrasonic machining have some limitation. Again, water jet machining have some limitation. Okay, and the most important is that chemical energy is used, sorry, mechanical energy is used to remove the material. Now in that again, or we can call here kinetic energy, chemical mechanical energy means what? Kinetic energy of either your abrasive particle or water jet. Okay, it is used. Okay, for what purpose? To remove the material from where? From the your workpiece. So if you use the kinetic energy of abrasive particle, the kinetic energy of abrasive particle means what? That velocity of your abrasive jet. Okay, when it will strike to your workpiece, no, then and then only erosion action will take place and material removal will be happening. Okay, so here kinetic energy of your abrasive particle or water jet. In case of water jet, water jet kinetic energy of water jet, it is utilized for removal of material from the workpiece. Now, in case of abrasive water jet machine, that is called AWJM. Here also we uses kinetic energy. Okay, for this abrasive water jet machining also uses kinetic energy of your abrasive particles. But here that abrasive particles will flow along with the water jet. So due to that only we have combined that abrasive and water jet. So kinetic energy of abrasive particles flowing along with water jet, it is used to remove the metal. Okay, and if you consider the finishing, no, finishing process under mechanical group, then magnetic abrasive finishing is there. Okay, that is another process in which magnetic abrasive brush it is used or it is utilized to reduce the surface to reduce the surface irregularities, okay, from the whatever the pre-machined surface is there. So it's a new finishing process. It is called abrasive flow machining, we can call. It is also recently developed process. Okay. However, what are the performance of this process are there? No, it is totally depend upon the hardness, strength, and another physical and mechanical properties of your workpiece. Okay. So what is really needed is the your development of machining method. Okay, which performance is unaffected by the your physical or metallurgical and mechanical properties of workpiece. That point also we need to consider. So what are the limitations of this first group is there, no? Okay, that is overcome by the your second group. Okay. So what are the thermoelectric methods are there, no? So they are able to overcome the some barriers or drawback of your mechanical energy based process. So therefore we can call thermoelectric process as well as your that last group electrochemical process are more and more deployed in the metal working industry. Okay. Now in this second group, no, that in electric method, sorry, thermoelectric process or method, here energy, what are the our energy is there, no? That electric energy, normally it is supplied in the form of heat. That means that heat, electric energy is converted into the heat. Okay. Now again that heat, if it is in the form of plasma, no, then your plasma arc machining will be there. If your heat is in the form of light, then laser beam machining will be there. If your heat it is in the form of electron bombardment, then electron beam machining will be. So like depending on the form of heat is there, no, what are the forms of heat is there, no. So depend on that your thermoelectric process are divided. Okay, like laser beam, electron beam, plasma. Okay, but here what are the energies there also, that energy is concentrated normally onto the your small area of your workpiece. Okay, and that when if you concentrate the heat on your small portion of or small area of your workpiece, no? So then that would result in your that melting or vaporization, and in some cases melting as well as both that your vaporization will be there. And due to that action, melting and vaporization, so due to that only metal remove will be happen. Now in case of the if you take the plasma arc machining, no? So that normally that plasma arc machining has been identified as a rough machining process. Huh? Plasma arc machining process has been identified as rough machining processes. In other way, in another side, whatever our laser beam machining is there, no, as well as the electron beam machining, that are very good. Okay, or we can call good enough for making very fine cuts and holes. Okay, in your workpiece. Okay, and however the another category is there, that another process, that is electric discharge machining. Okay, so that is a process which is capable of machining the metals economically as well as accurately, and this process is normally used or widely used for machining hard and tough but electrical conductive metal should be there. Okay, so about EDM, that is. So, and again the drawback or the limitation of this electric discharge machining, that it is unsuitable or not suitable for many applications where very good surface finish, low damage to the machined surface, and I can call high material removal rate is, you know, if these are the requirements will be there, no? So that time this EDM machine is not suitable. So I can say the mechanical and thermal processes of this advanced machine processor, they do not offer any satisfactory solution to some of the problems, some of the problems of your machining, uh, which are the materials were difficult to machine. So for that, in some cases, this process also not give the satisfactory solution. Okay. Again, if you could talk about the in detail about the this third group, no, that is EO2 chemical and chemical. In that again, that chemical process. So that I will repeat once again that chemical process is there. So it's process normally, and which have very narrow range of application mainly, like your what do you call ingrain operation. It normally it is carried out using the chemical machine, but here material removal rate is very low. Okay, and there is difficulty in finding the suitable agent also for a given workpiece. Okay, so because whatever the properties are there not your workpiece, so depending on that property you need to select the agent during the chemical machining. So there is a limitation of this chemical machining also. Then electrochemical machining is there also, that ECM. It has a wide variety of application normally. Okay, so it is normally controlled by anodic dissolution process. Okay, so that leads to high metal removal rate. Okay, again which is independent of any physical and mechanical properties of your work. Okay, but here one condition again is there for ECM, that is your work metal should be electric conductive. Okay, so again in this ECM process there is no tool wear. Okay, then again no residual traces, then thermal damage whatever it is caused due to workpiece material, no? So that will not be issue in this ECM. Okay, there is also no burr on the your machinery edge. Okay, so in some cases your advanced machining process cannot be fully replaced by the conventional machining process. So that point also we need to take into consideration. Okay, so while selecting the process which is you are going to use now, so some factors you should be uh, uh, take into the account, that now which are factor while select which are factors which from that factor we can select the your best suited process. So that factor means your process capability, then physical parameters, then shape to be machine, and some properties of your workpiece method to be cut, and lastly economic of your process. So this point generally you need to consider while selecting the process. Okay, so this is about the classification. Okay, in the next lecture we'll go by one again in detail. Okay, okay, actually chapter 1 is started. Okay. Now again, so to overcome the some we can call difficulties or the limitations of this advanced machine processes, so to further enhance the capability of these processes, machine processes, no? We can go for combination of two or more than two machine processes. Okay, so that will get the or we can take the advantages of this worthiness of the your constituent process. Okay, so if you go combination of two or more than two advanced machine processes, then whatever we get new process, it is called the hybrid process. Okay, so that also take into the account. Okay, for example, if you combine your conventional organic process, okay, uh, along with your that electrochemical machining, then it is called electrochemical grinding process. Okay, so electrochemical uh, machine plus your conventional will get the electrochemical grinding, like that. And another process like electrochemical spark machining is there. Okay, then electrochemical arc machining is there, electrochemical arc machining, then electrodischarge abrasive machining is there. So these are some hybrid processes also there. Okay, now next lecture we'll discuss one by one. Sorry, first we will go for difference and then we'll go for overview. Okay, now let me take attendance, then you can in this lecture. Okay. Now you can write your roll number in the chat box.